Yeah, hello all. This is a session about Spark. Spark as the general purpose engine for big data computing. So let's take it. Let's take it ahead. What is Spark actually? Spark is a fast general purpose computation engine for large scale data processing. So this is the official definition from the Apache, but typically it can be used for any kind of computation, not only rather for big data, but also for computation on any kind of data that comes from data warehouse or a database or from a flat file system. So you can use Spark for either of the languages. So Spark is actually you can write Spark on Java, Scala, and Python, on all the three languages. So here we will be seeing about writing it in all the three languages. The language is never a barrier of choice, um, but Spark itself is being written in Scala actually. So it's better to write it on Scala, so you know the internals of how the Spark is being written. But language is never a barrier of choice, so you can either choose Python or Java too. So going ahead, the history dates from the development of MapReduce, but typically Spark was developed by Matai Zaharia in the Berkeley Labs. In the Berkeley Labs, there is a specific department called as the AMP Lab. AMP stands for Algorithm, Machine, and People. And in order to commercialize Spark, the founders founded the company called as Databricks. So you will find a lot of technology and open source and libraries coming from Databricks. So Matai Zaharia was the founder, and the Spark was developed in around 2013. Now it's a full-grown Apache top project running full-fledged, and it's one of the top big data projects. Going ahead, what is the advantage of Spark? So one is fault tolerance. The reason being the data is distributed and across the cluster wherever it is, and it regains its cluster through RDD lineage. So that's the fault tolerance of the factor. Because Spark, Spark data structure is actually RDD, called by the name resilient distributed data. The term resilient stands for fault tolerance. That's the ideal impact of it. So, by in default, through the RDD lineage and the distributedness, the fault tolerance is being achieved. That's one thing. Second thing is it's taking the computation to the data. All traditional systems, all traditional storages take the data to the computation, but in terms of big data, it's actually taking computation to the data. And the high level of plumbing of high level of framework development code, by which the plumbing of the code is hidden for you. And here you have the framework. When compared to MapReduce, you have a high level APIs supporting you in the development, so you can focus more on the business logic rather than on the programming code. The third thing is it caches data in the memory. Spark does all its data in the memory, and the complete computation is there in the memory, so nothing is there in the disk. So that's the major advantages. These are the top level advantages when you compare Spark with other frameworks like MapReduce or Flink or so. Going ahead, what are the other stuff that we have is the lazy computations. Any RDDs are lazily computed, and of course, whatever the data that's been read is actually computed in the memory for computation. So these main core advantages make Spark one of the best programming languages and the programming framework in order to be adapted to. So for Spark, the core components of Spark are Spark Streaming, Spark Machine Learning Library, Spark SQL, Spark Graphics, BlinkDB, Spark Core, and the underlying storage is actually HDFS. Your application basically sits on top of this. So the core library of Spark you run it in Spark code, and if you want to stream the live data from an Twitter streaming or Socket or from RabbitMQ or ActiveMQ, you use Spark Streaming. And if you want to do machine learning on top of it, it's MLab. And Spark SQL is the SQL on top of Spark, and GraphX is the graphics library on Spark, graph-based library on Spark. And BlinkDB is a time-bound dimensional DB on top of Spark. So together, all this is called by the name Berkeley Data Analytics Stack, which is a BDAS, which is there. The complete BDAS I have proposed it here, and this is actually from the App Labs of Berkeley. You can go and refer it there. So Spark is one such component over there. So there are other components in it. So whichever you touch would become a standard in the big data industry. So it's good to learn and good to know the other components too. But here we will be finding detailed analysis about Spark and Spark streaming and the stuff. Okay. I'm going to stop with this for this introductory session, and we'll go ahead in the next session.